Hello, welcome. Today let's try to solve Leetcode problem 98, validate binary search tree. So we are giving a root of the tree. We are going to check if this binary search tree is valid or not. As we know about the binary search tree from the root node, if it is the node from the left side, it is always smaller than the root node. So this one is smaller than 2. And from the right side, this value 3 is always more than 2. So this is valid. And for this one, so 1 and 5 is okay. But for this 4, from the right side, the node should always be bigger than the root node. So it means 4 is less than 5. So it means it's gonna return a false because it is not valid. Yeah, and we're gonna recursively check for the subtree if the left side is smaller and the right side is bigger. So for this subtree 3, 4, and 6, it is okay, it's valid. But for this 4 with this 5, it is invalid. Yeah, so we can solve this problem from pre-order traversal, in-order traversal, or post-order traversal. But I think the pre-order traversal is the easiest. So I'm gonna use the pre-order traversal. So I will first check the root node. If this root node is valid, and then I'm gonna check this left and right subtree. So for the left subtree, I'm still check the root node. If it is valid, I'm gonna check the left and right subtree. Yeah. So I will prepare some boundaries because I want to check the first node 2. If it is valid, it means 2 should be bigger than the left boundary and smaller than the right boundary. Yeah, so I would prepare an infinite variable as the left and the right boundary. So the left would be infinite and right should be, yeah, so the right should be infinite and left should be negative infinite value. Now I'm going to check if not root. Yeah, so it means if the root is not exist, I gonna return a true. Yeah, or when I traverse the tree by pre-order traversal, when I go to the node 1, if it is valid, and then it go to the left and right. So for the left and right node, while the node is not exist, so I gonna return a true. So for the final function, I'm sure I will return a true. Now I will take the value out of the root node. So the root.val should be, yeah, v should equal to root.val. And then I can return the final result. So this value of v, so this is the root node, this 2 should be bigger than L and smaller than R. And also I need to check the is valid from the left side and the right side. Yeah, so the root dot left. If I check from the left side, it means I need to update my right boundary. So for example, this 2 goes to 1, and for the left boundary, it is still the negative infinite, but for the right boundary, it will be updated to 2 because this one is coming from the node 2 from the left, yeah, from the root node. So the root goes to the left. So this one, for the right boundary, it would be updated to the value of v. So for the left boundary, it will be L and v. Yeah, and similarly for the right branch, it would be root dot right, and the right boundary would be v and r. So if I go to 3, so the right boundary would not change. It would still be the infinite, but for the left boundary, it would be updated to 2 because this 3 is coming from the root node 2, and this 3 is the right branch. Yeah. Now let me run it to check if it works. Yeah, I need to use a self because this function is directly from the class. So let me add a self. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases.